Hello, class. This is Dr. Denton. Thank you so much for submitting your assignments on time for week 2. This is week 3, and we will be discussing sampling distribution and statistical experiments. So as you can see here, we have different models. The models are, the model distributions are long tail distribution, student T distribution, binomial distribution, chi-square distribution, F distribution, and Poisson and related distributions. There will be more on confidence intervals, sample size selection, A/B testing, hypothesis testing, multi-arm bandit logarithm, along with power and sample size. The long tail distribution, these are some of the terms. The tail, which is here, the skew, along with the normal distribution, that's where it typically does not characterize the distribution of the raw data. Most of the distributions are highly skewed. So as you can see here, here's the head, this is the tail. The student T distribution, these are some of the key terms. N, that is your sample size. The degree of freedom is a parameter that allows the T distribution to adjust to different sample sizes, statistics, and numbers of groups. If we are interested in estimating a population, meaning you, with a sample size of N, we'll assume the population distribution is normal with unknown standard deviation sigma. Sigma is placed by the sample standard deviation S, so as is shown in this equation, as you can see here. This is a graphic of the T distribution, and it looks pretty much like the standard normal distribution. It is a bell shape and center at 0. The only difference is that it is slightly more spread out, and this increases in speed is greater for smaller degrees of freedom. When the N is large, so that the degree of freedom is large, the T distribution and the standard normal distribution are practically indistinguishable, as shown below. So these are some of the key terms for binomial distribution, and they are trial, success, binomial trial, and binomial distribution. And some of the key ideas are below. The chi-square distribution, and here are some of the key ideas. The chi-square distribution is typically concerned with counts of subjects or items falling into the various categories. And as you can see here, the chi-square statistical measure. The F distribution, these are some key ideas for the F distribution, and it is used with experiments and linear models involving measured data. The F static compares variation due to factors of interest to overall variation. These are some of the key terms for the Poisson and related distributions. They are lambda, the Poisson distribution, exponential distribution, and well-built distribution. This is some more on confidence intervals and the population. As you can see here, the very first one is let T be a population total that you want to estimate. First, you will need a point of estimate of T. for the population of T, as you can see here. This is the total to the population with this equation. The mean and standard deviation of the sampling distribution of T are given in this equation below, as you can see here, and as you can see here. Because sigma is usually known, S is used instead of O to obtain, or sigma, to obtain the approximate standard error of T given in the equation below, as you can see here. The point estimates of T is the point estimate of the means multiplied by N, and the standard error of this point estimate is the standard error of the example, and that means is multiplied by N. This is more on confidence interval. This is the standard error. Basically, surveys are often used to estimate proportions. So it is important to know how to form a confidence interval for any population proportion. And these are the basic procedures required a point estimate. As you can see here, point estimate, plus or minus multiple times standard error. And also it can be shown that for sufficient large N, the sampling of distribution of P is approximately normal with P and the standard error, as you can see right here. This is a standard error of sample proportion and the confidence interval for a proportion here. And as you can see here, the confidence intervals for proportions are fairly wide unless N is quite large. To obtain a 95% confidence interval of 3% points of a population proportion, where the population consists of millions of people, only about 1,000 people need to be sampled. When auditors are interested in how large proportions of errors might be, they usually calculate one-side confidence intervals for the proportions. As you can see, this is an example of it here. And this is just more on confidence intervals. Just make sure that you go over and read all of your slides here. This does talk about the chi-square distribution, and the appropriate sampling distribution is a right skew distribution, and it's called the chi-square distribution. The appropriate sampling distribution of the difference between sample means is the T distribution and N1 plus N2 minus 2 degrees of freedom. And as you can see here, this is the confidence interval for differences between the means. And this is the equation for that. The pool estimate of common standard deviation. This is your equation for the pool estimate of the common deviation, and also the standard error of distribution between sample means. And as you can see here, this is another equation that you want to make sure that you look at the appropriate standard error of this particular SE, as you can see there. So this is if there's a reason to believe that the population variants are unequal, a slightly different procedure can be used to calculate a confidence interval for the differences between the means. When the samples to be compared are paired in some natural way, such as a pre-test or post-test for each person, or husband-wife pairs, there is a more appropriate form of analysis that the two samples, the procedure. The paired procedure itself is very slightly forward. And as you can see here, these are the procedures here. It does not directly analyze two separate variables. For each pair in the sample, calculate the difference between the two scores for the pairs. Then perform a one sample analysis on these differences. The basic form of analysis is the same as in the two sample analysis for differences between means. However, instead of comparing two means, we now compare proportions. Confidence intervals for differences between proportions. This is the standard error of difference between the sample proportions. Confidence intervals are a function of three things, and they are the data in the sample directly affects the length of the confidence interval through the sample standard deviation. As confidence level increases, the length of the confidence interval increases as well. The sample size is R, the most obvious way to control confidence intervals. The length is to choose the sample size appropriately. The goal is to make the length of a confidence interval sufficiently narrow. The confidence interval discussed so far is a point estimate plus or minus some quantity. The most appropriate sample size for estimation of the mean can be calculated from the formula for the confidence interval for the means by setting, and this is your equation for that. Unfortunately, sample size selection must be done before a sample is observed. And value is S is not yet available. And the resulting sample size is this equation here. Then we have the A/B testing, where there is a formulate hypothesis, design, experiment, collect the data, inference, and conclusion. So this is basically the classical standard inference pipeline. These are some of the key terms for A/B testing: treatment group, control group, randomization, subjects, and test statistics. These are some key terms for the hypothesis testing: null hypothesis, alternative hypothesis, one-way test, and two-way test. Resampling. These are some of the key terms for resampling. And there are the procedures to combine two or more sample together and randomly recollecting and observing the sample to resample, resampling along with or without replacement in sampling, whether or not an item is returned to the sample before the next draw. Okay, so this is per mutation test, where you would have these 6 steps here. So just make sure that you read through all of these. Along with the bootstrap per mutation test, where you combine the results from the different groups into a single data set, you shuffle and combine and then narrowly draw from the remaining data, randomly draw, and then you do the same for groups C, D, and so on. Whatever statistics or estimates were calculated for the original samples. You would calculate it now for the resample and record. This constitutes 1 per mutation iteration. Repeat the previous steps R times to yield a pre-mutation distribution of the test statistics. These are some key terms for statistical significance and p-value. P-value, there's a term there for p-value, alpha, along with type 1 error and type 2 error. P-value is the frequency with which the chance model produces a result more extreme than the observed result. The alpha is the threshold. The type 1 and type 2 errors, which a type 1 error is which you mistakenly conclude an effect is real when it is really just due to chance. The type 2 error is which you mistakenly conclude that an effect is not real when it actually is real. Some of the terms for the t-tests are test statistics, t-statistics, t-distribution. So all of those are key terms for the t-tests. Multiple testing are type 1 error, false discovery rate, alpha inflation, adjustment of p-value, and overfitting. These are some of the key terms for ANOVA, pairwise comparison, the omnibus test, decomposition of variance, F statistics, and SS, which is the sum of squares. And this is the EK, the stickiness of for web pages defined as the number of seconds a visitor spent on a page. So you can just kind of go through here and see, what the 4 means are, what the average is, what the grand average is, and all the information. So just make sure that you definitely pay attention to the ANOVA. And then the key terms for chi-squared are chi-squared statistics, expectations or expected. And what that is how we would expect the data to turn out under some assumptions, typical the null hypothesis. And these are some more chi-squared tests. As you can see here, the test with the sampling logarithm, and you can see this information here. And this is expected if all 3 headlines have the same click rate. Some of the key terms for multi-arm bandits are multi-arm bandit, which is an imaginary slot machine with multiple arms for the customer to choose from, each with different payoffs. Here, take to an analogy for a multi-treatment experience. The arm and the win. The arm is a treatment in an experiment, a headline A, and a web test. So the win is the experimental analog of a win at the slot machine. So the customer clicks on the link. And these are some key terms for power and sample size, effect size, power, significant level, all of this information. And as you can see here, this is a great way of how you would approach to know approximately how much data to collect. And that is the end of our presentation for, oops, sorry about that. Go back and share the screen again. Sorry about that. All right, here we go. All right, so that is pretty much it for our week 3 presentation. Again, this particular week is discussing sample distribution and statistical experiments. So just make sure that you go over all of your coursework. Just remember that all assignments are to be due by the due date to get full credit for them, along with making sure that you are looking at your announcements in the event that there are updates throughout the week. So that is pretty much it for week 3. Have a really great week, and let me know if there's anything that I can do to help and support you. Thank you. Have a great week.